Mabuhay! Welcome to another series of Sir Jeryl Explains. Today we will learn all about the topic energy, underlying potential and kinetic energy. This will be lesson 2.3, so let's get right to it. What comes to your mind when you hear the word work? Work has a lot of meaning. It can refer to a job, task, or everything we do that requires us to move. In physics, work is an abstract idea that is related to energy, because an object need energy in able to do work. Examples of work. Consider the following street game, tumbang preso. A slippy is aimed towards an empty can to knock it off. When a slipper is thrown by a person, an applied force is exerted on it. Thus work is done. The slipper, applied force when thrown, possesses kinetic energy. To knock out the can, which is the stationary. As the slipper interacts with the can, it loses energy, while the can gains the energy of the slipper. This tells us that objects that are in motion has energy and can do work. Energy is the ability or capacity to do work. Do note that the unit of energy is the same as the unit of work, which is joule or J. Also remember that 1 joule of energy is needed to accomplish 1 joule of work, meaning the amount of energy in joules is equal to the amount of work done in joules. Work is related to energy. To be able to do work, energy is needed. So now, when do we say that work is done? Example of work is moving and pushing a rock. Explaining this, work is done if the object being pushed moves in a distance to the same direction where it is being pushed. In contrary to that is, pushing towards a wall. There is no work done here, as the force exerted by the girl did not make the wall move. By these examples, we can say that work is done only when force makes an object move in the same direction as it is exerted. Now let us tackle potential energy and kinetic energy. Potential energy. It is the energy stored in an object or substance which is based on its position, arrangement, or state. To better understand, work is a way to transfer energy. So when a man exerted force in lofting the box, he loses energy. The person or the one lifting loses energy. Why the box that is being lifted gains energy. Looking back at previous topics, the force of gravity is the force exerted by the earth and all things. It is always directed towards the center of the earth. When an object is raised from the earth, the force exerted in lifting the object is equal to its weight. So technically the force exerted is equal to weight of the object. We write it as force is equal to weight is equal to mass times the value of gravity, or can be written as F is equal to weight is equal to mg. The work done in lifting an object can be computed as work is equal to force multiplied by displacement. Displacement is the height that the object is raised, or can be written as W is equal to F multiplied by D. Similarly to that formula, it can also be written as work is equal to mass acceleration due to gravity multiplied by height, or W is equal to mg multiplied by h. In potential energy, work done in lifting an object is equal to the potential energy gained. It is written as potential energy is equal to mass acceleration due to gravity multiplied by height, or PE is equal to mg multiplied by h. Now let's try to apply the formulas and try to compute. Jenny lifted a book with a mass of 1.5 kilograms at 0.9 meters above the floor. What is the potential energy gained by the book? First let us write. The given mass is equal to 1.5 kilograms. Height is equal to 0.9 meters. Gravity is equal to 9.8 meter per second squared. We are going to use the formula of PE is equal to mg multiplied by h. Now let's substitute 1.5 kilograms times 9.8 meter per second squared times 0.9 meters. It will have a total of 13.23 kilogram meter squared, second squared, or 13.23 joules.